Okay, so we're going to continue on with the rest of volume here by talking about composite figures. They're going to try and trick you with these problems by giving you a limited amount of information here. You have a cylinder on top of what looks like a cube, and I guess we need to look at their directions. It says that it is an oblique cylinder on top of a cubic base. So, since we know that this is a cube, we know that all of these sides are all going to be the same, but they don't tell us what those lengths are. They tell us that the entire height is 22 feet, and they tell us that the radius of the circle is 5 feet. So how can we use that information to figure out how long each of the sides of the cubes are? By the way, you should probably write down what the volume is. The volume is going to be the volume of the cylinder, which is pi r squared times height, plus the volume of the cube, which is going to be, I think they use S in our directions, so we'll say S. So we'll say S cubed. That's going to be our formula. We know that the radius is 5, which means that this base is 5, which means if we stretch it all the way across, that's also 5. So that means that our side length is 10. So that means that we have S is 10. We can write this as 10 cubed. If this height is 10 and it goes all the way up to the top and the top is 22, then we could say that 22 minus 10 would leave us as 12. So the height we're using here is 12. We know that our radius is going to be 5 feet times pi. We could write our volume in two different ways, one in terms of pi and then one not in terms of pi. We could do 25 times 12, so that's 25 times 12 pi, whatever that is. I'm putting my pi afterwards because we're going to have some number pi, plus 1,000. And then 25 times 12, let's see, that's 250 plus 50 more, that's 300. Pi plus 1,000, and that's going to be our volume. We could say this is going to be feet cubed, or we can round to the nearest tenth. Had to go get my calculator here. Professional video, by the way. 1942.47. I don't know, what's our directions? What does it say? Round to the nearest anything? Okay, well, there you go, 0.5 feet. I had 0.47. Feet cubed. Cool. Let's look at another composite figure. This one is made up of two congruent cylinders. So we could say one of these volumes times 2. And two congruent triangular prisms, each of which is a cube cut in half along its diagonals. Which means if we think about this, we don't even need to consider this triangular prisms as triangular prisms. We could say that it is a cube cut in half, and there's two of them, which means that it's a cube. So if we write this in words, it's going to be the volume is cylinder times 2 plus cube. So that seems like we have the same problem as the one above. The only thing they tell us here is 36 pi. That's the area of our base there. Do we get any height? It says the height is 6 times the length of its radius. So h equals 6r. We know that the area of our circle is 36 pi, so we could say 36 pi equals pi r squared, and then we need to solve for r, and it looks like that r is 6 because 6 squared is 36, so r is 6, and if r is 6, 6 times 6 is 36, so our height is 36. And then we can look at, well, if our radius is 6, then how long is it across? Well, that's just going to be 12. So S is 12. And now we can plug in all the information we have here. Our cylinder is pi r squared times height times 2 plus our S cubed. So we have pi, our radius is going to be 6 squared, our height is going to be 36. We're going to multiply this by 2. We're going to add this to our side of our cube, which is 12 cubed. So we have 36 times 36 times 2. That's going to be 2,592 pi plus 12 cubed. That's going to be 1728. And if we were to round that, looks like I will get 9,871. What's my units? Oh, inches. Inches cubed. It's 9,871.008, so we'll round it off to that. Okay. For number 8, we're just going to reflect here and think about how could we find the volume of this. It says that a pipe consists of 2 concentric cylinders. That means that they're the same height. The one is inside the other, with the inner cylinder hollowed out. Describe how you can calculate the volume of the solid pipe. So we want to find the volume of this. And we remove the inside. So, well, we could take the volume of the big guy. The big guy's radius is going to be pi r1 squared times height. And we're going to subtract the inside one, which is r2. So pi r2 squared times height. Now, for your assignment, all I want you to do is these 4 problems plus page 932. So there you go. I'll see you later. If you have any questions, let me know.